All right, so let's do number 26. As their booster rocket separates, space shuttle astronauts typically feel acceleration up to 3 times g, where g is 9.8 meters per second squared. So let's write that down. G. In their training, astronauts ride a device in which they experience such an acceleration as the centripetal acceleration. Especially, the astronaut is fastened to securely at the end of the mechanical arm. So let me draw this. So this is going to be the mechanical arm. And we're going to pretend that this is going to be a rocket. And see if I can draw this. I'm trying to draw 3D here, but this is just a sketch anyways. And here's a rocket, folks. And here's the astronaut being strapped in this device. And this thing is going to go around in a circle. And that is centripetal acceleration, 3g, or maybe it's the other way around. Maybe he's hitting in the opposite direction. It doesn't really matter. But these, I don't fully know this, so. But the centripetal acceleration here is going to be 9.8 or 3 times g, so 3g. And I think that's it. Yeah. And do they give the radius of that? As a rocket, space shuttle, in the training which they experience, especially the astronaut at the end of the mechanical arm, and that end turns at a constant speed of a circle. Determine the rotational rate. Ooh, the rotational rate. Oh my god, I was a little confused because he only gave the acceleration. All right, folks, we are going to determine the rotational rate. So I'm going to do this. I'm going to put it in V. I don't know what symbols they use. So I'm just going to... So we are going to be giving the 3g. Now, remember, folks, this 3g is not it's not the acceleration of the rocket. The actual acceleration is actually in here towards the mechanical arm, towards its center. The reason why I put it out here is because this object is not going to move. But it will experience an acceleration. That acceleration is going to, you're going to feel a pull towards the rocket, towards the end at 3g times the g as this rocket is rotating. And that's realistic, folks. So that's why this centripetal acceleration is, we have a formula, and that's going to be v squared over r. Derived by geniuses of people. So this is going to be the centripetal acceleration. Now, the thing is asking for determine the rotational rate. So look at the keyword, rotational rate in revolutions per minute. So the rotational rate is going to be, so the tangential speed, so that's basically this. That's basically this omega right here. How much of this omega changes? How much a circle with the radius 1? How much this arc length changes? So it would be the same as how much of this tangential speed changes if you multiply this by the radius. So omega. And once we put this formula together, and this, I guess we call this the big radius, then let's pull this together and say that A equals r square omega square over the r. So omega, the rotational speed is going to be a times the radius, or a divided by the radius, square root. And there we go, folks. So, all right, I hope this helps you guys. I hope these videos are becoming very fruitful for you guys. So A is going to be 3 times G. So I'm going to replace this with a variable. So this answer is going to be root 3 times gravity divided by the radius of the thing, which they didn't give it to you, didn't? Oh my god. All right, folks, so the omega is going to be the omega is going to be root 3 divided by the radius, which they did give it to us, is actually 9.45 meters. So 3 times 9.8, 9.45. So I'm going to put this in the calculator, guys. The square root of 3g divided by the radius. But we're not actually quite done yet. So this gets us as 1.76 meters per second. Let me check the units here. So that's meters per second squared divided by that. I'm a little confused right now. So the unit does check out. So the radiocircular, so the omega, the angular speed is going to be 1.76 radians per second. So we want to convert this into we want 2 pi radians to be 1 rev. Radians is going to be 1 rev, 1 revolution. So what we're going to do is we're going to divide by 2 pi to make this into rev. So we're going to take 2 pi of this value that we found. Let me write that down. 3g. Okay. So we're going to divide that by 2 pi. So we have 0.28 revs. That's pretty fast. So maybe we change this. So the omega is going to be 0.28 radians per, or rev per second. That looks very slow, actually. What the fuck? Anyways, folks, this does look, the math does check out, so I'm going to presume that this is correct. So what we found, folks, is we found how many revs per second. For every 1 second, how many revs is that? So since this is 9.45 meters long, I guess that makes sense. So anyways, folks, I hope you guys enjoyed.